students, today we are going to study about the Cartesian product of any given sets. Before starting the given topic, I would like to tell you that when do we use it and in which topic we are going to apply this. In the previous chapter, which was set theory, we have studied about the sets, we have studied about the relations of the sets, and then we had applied the given rules and applications on sets we have done. Now here we have to study the next chapter, which is relations and functions. In this chapter, first of all, before knowing about the relations, we must be knowing that how can we multiply any two given sets. Now we are knowing that how to add any two given sets and how to subtract and how to find the union, how to find the intersection of any given sets. Now we must be knowing, before knowing about relations, that what is the Cartesian product of a sets, of any given sets. So for example, suppose you are going to multiply any two given sets. So it is not a just like a if you will add or subtract any two given sets, the resulting addition, sum or difference will be again in the form of a set. But when do we multiply any two given sets or any number of sets, then we are not getting a set again. It is actually a set whose elements are there in the form of ordered pair. Okay. So if the numbers, if the products so obtained are in the form of ordered pair, just like we see that in the Cartesian plane, we can plot the points on the Cartesian plane if they are in ordered pairs. Okay. So similarly, for example, if we are multiplying any two given sets, suppose A is 1, 2 and B is A and B. So if we are multiplying A and B, it is not only 1, 2, AB or 1A, 1B, 2A, 2B. We have to write them as the coordinates, just like in the form of ordered pairs, right? So first of all, we have to take one element, first element of first set, and then we have to multiply and make the ordered pairs from each of the element of the given second set. So for example, it is 1 here, so we have to make ordered pair with 1 and A, 1 and B also. And we will write obviously in the form of ordered pairs like this, 1A, then comma 1B. That is a product of 1 with all the elements of set B. Now we will choose the second element of set A, which is 2 here. Then again we will make the ordered pairs of 2 with A and B both. So this is 2A and 2B. So in this way we need to multiply any two given sets. Suppose there are some more number of elements in set A or B, then also we have to increase only that. We have to introduce some more ordered pairs which are there. Okay. So that is the way how to multiply it. Now this was one example only. But before that, I would like to tell you the definition. What is the Cartesian product of any given sets? So let's see the definition first. Definition is saying that for any non-empty sets A and B, the Cartesian product A into B is defined as such that it is what? AB. AB is written in the form of ordered pair. We write ordered pair like this. You know coordinates, you know how to write. So A and B are the element, ordered pair is the element of the Cartesian product of A and B, such that A belongs to A, that means small a belongs to set A, and small b belongs to set B. That means the first element of the ordered pair will be obviously in the set 1, and the second element of the ordered pair which will be obviously in the second set. That is known as ordered pair. Now since it is ordered pair, so obviously order matters here. Suppose that if at the place of AB we are writing BA, then the whole meaning will change. Because it is ordered pair, and if we are changing the order, that means we are changing the order of multiplication also, right? So we cannot say that in the multiplication or in the Cartesian product, AB is never equals to BA. Okay? If we are changing the order, that means we are changing the meaning of the product also, right? That we will discuss later on. But first of all, you must be knowing that what is the Cartesian product of any given set, right? So Cartesian product is what? It is the multiplication of elements of the given sets, and we have to write the product in the form of ordered pairs, but the first element will belongs to set 1 and second element of the ordered pair will belongs to set B. Now, the second thing is here, second thing is what? If we are writing the ordered pair in the form of Cartesian product, you know, I have told you already that it is important to write in order. If you are changing the order, that means order of multiplication is also changed. Second thing is that if you are writing the Cartesian product of any two given set, it is always in the form of ordered pair. But for example, if you are multiplying any three given sets, suppose there are three sets A, B and C, then how will you write? Then it is defined as ordered triplet. We write like A, B, C such that A belongs to set A, B belongs to set B and C belongs to set C. Right? That means if there are three sets to be multiplied, then we have to write the ordered triplet. That means group of three numbers. As you can see here, we will write again in the bracket and they will be the group of three numbers, and where the first element will belongs to set A, second element will belong to set B and third element will belong to set C. That means in order we have to write again, but they will be the group of three numbers. Okay. So it is very simple to understand. If there are two sets, so the ordered pair means the group of two numbers, you know exactly. Okay. If there are three sets, so there will be group of three numbers, which is known as ordered triplet, and so on. If there are four elements, if there are four sets, there will be four elements in the ordered pair in the group. Okay, and successively they will belong to the given sets, but they must be written in the particular order. Order matters here, right? Now I would like to give you one more example of the product of three sets. How will we multiply any three given sets? Right? Let us take some example. A is equals to 1 minus 1. B is equals to AB. And C is equals to XY. Right? We have taken three different sets here. Now we will multiply A, B and C. Let's see how will we multiply any three given sets now. What we have to do? We have to choose first element and then we have to multiply it by the elements of second and third set. Write all the possible pairs which can be formed with 1. 1 can be 1, A and X. Second can be 1, this is 1, A and we are changing it to Y. One more thing can be done. 1 can be multiplied with B also. What we had done? We had fixed 1 and A here and changed X and Y. Now we are changing this middle element, second element we are changing. That means 1 can be multiplied with B also and X and Y also. So first we have written 1A. Now we will write 1B and X and Y. So this is 1B X and 1B Y. Now you can see that we have multiplied with all the elements. 1 is multiplied with A and B both and X and Y also. Now we will pick minus 1 here. Minus 1, this is the next ordered pair. Minus 1 will be multiplied with A and X. Next can be written as 1 minus 1 A and Y. Minus 1 and A, minus 1 and A and X and Y. Now we will change this element which is A. Now we will multiply it with B. So minus 1 B X and minus 1 B Y. Now there is one more thing, that how many ordered pairs will be there in any Cartesian product of sets, of any given sets. So there is a formula to count the number of ordered pair or ordered triplet, to count that if we have done completely or not. So for that, just like if you had multiplied two sets, I had given you first example. In that there were two sets, and each of the set was having two elements in that. So in that case you got four ordered pair. I am giving you again that example. Suppose it was 1, 2 and B is x and y, right? So if you are multiplying A and B, what you are getting? You are getting 1x, 1y, 2x and 2y. So number of ordered pairs you can see it is 4. How do we get? If it is having n element and if it is having m element, then obviously A into B will have mn or nm elements in that, or ordered pairs you can say. Similarly, if A, B and C are any number of sets are there and we have to multiply them, then the ordered pair or ordered triplet will be the product of all the elements, will be equal to the product of the elements. So what we have here? We have two elements in each of the sets. So how many ordered triplet we will get? 2 into 2 into 2. That means 8 ordered triplets we will get in the Cartesian product of this. So see, if how many we have written? We have written 1, 2, 3, 4, 5, 6, 7 and 8. That means all the possible ordered triplets we have completed. And you can see that, you can check it also that there is nothing which is left. Now you can say that, ma'am, you have written only 1 and minus 1 here. You have changed the second and third element place, but you have not changed the place of 1 and minus 1. Why? Why we can't write A at first? Because it is ordered triplet, and order means we have to start from A and then go to B and C. We can multiply A with B and C in any order, but we cannot multiply B with A. Okay? So this is the main thing which you have to understand. So this is the complete product, and after this you must be knowing that what is the number of ordered pair which can a Cartesian product have. So you can write a note. First is, if set A has n elements and set B has m elements, then number of ordered pairs in A into B is equals to Mn. That is, if Na is n and Nb is m, so you can write number of, that means cardinal number of A into B is clearly Nm or Mn. Okay. So this is the thing which you must be knowing, and similarly we can write the cardinal number for the Cartesian product of any given sets. If there are 3 sets, so you multiply all the elements, number of elements present in the given sets. That will give you the number of ordered triplet or ordered doublet or whatever is there. Okay. So that is the thing which you have to understand regarding the ordered, regarding the Cartesian product of any given sets. Next thing we will study in the next video. Okay. Thank you for watching.